Okay, today we're going to look at simplifying algebraic fractions or rational expressions, and we're going to look at multiplying and dividing these rational expressions or algebraic fractions. So it's really, really important to know how to simplify algebraic fractions when we're dealing with them. So this is a really key lesson for you to understand. We can only cancel when we are multiplying, when we have factors. So for example, in this first example, because a squared is the same as a times a over 2a, which means 2 times a, we're able to cancel an a from each of those because we are multiplying in the numerator and the denominator. So when we cancel those, we get a over 2, and now it's as simplified as possible. So same in part b, we're multiplying. We have 6 times a times b over 3 times b. So because, again, it's all multiplication, we can cancel a b from each of those. And we can also cancel a 3 from the 6 and the 3, because 6 divided by 3 gives us 2, and 3 divided by 3 gives us 1. So when we simplify that, we get 2a squared over 1, or just 2a squared. In this example here, we've got 3 times x plus 4 times x plus 4 over x plus 4. So because in the numerator they're all factors of each other, it's 3 times x plus 4 times x plus 4, we can cancel one of our x plus 4's because there's multiplication in between as our operation in the numerator. So when we cancel those, we get 3 times x plus 4, or if we wanted, we could distribute that 3 inside and we'd get 3x plus 12. So either way is fine. And this last one, we have a plus b over a. Notice there's no multiplication in the numerator, and there's not identical factors in the denominator. So because of that, there's nothing we can cancel. We cannot cancel our a's because there's no multiplication in the numerator. Notice we can't factor out an a from a plus b because b doesn't have an a included in it. So we just say, yeah, it is simplified. It's as simplified as it can get. Okay. It's always a good idea to start by factoring both the numerator and the denominator. So if we factor the numerator here, we have 3 times x plus 4 over 3x. So now we're dealing with multiplication, whereas before we just had addition in the numerator. So because we factored out a 3, and we have 3 times another factor, we can cancel our 3's, and we're left with x plus 4 over x. And we cannot cancel our x because there's no way to factor an x out of the 4. So this is as simplified as it goes. Here we can factor out a 3 and an x squared from both terms. So we have 2x plus 4. Oh, we can factor out a 6. So 6x squared, and then x plus 2. So this 6x squared, which is all multiplication, is being multiplied by the factor x plus 2. So because of that, we can cancel our 6x squared, and we're just left with x plus 2 over 1, or just x plus 2. This cancels to 1 and 1. Okay, so here's some for you to practice. I'll write the answers up here, but it'd be a good idea for you to pause the video, try these examples, and then check your answers with mine. And here are those solutions. Notice in this first example, you could factor out even more. You could factor out 20, which is totally fine. So you could have 20 times x plus 5 over 5x, but we can only cancel 5, which is 1, and a 5 out of here, which is 4. So either way, you'll get the same answer. So whether you factor in a 5 from the start or 20 from the start, you'll end up with the same solution in the end if you distribute that 4x inside. And you don't have to either. You could say, well, it's 4 times x plus 5 over x, and this is equal to this solution. So either one is good. Okay, again here, you should pause the video, try these examples, make sure you can do every single one of them, and then if you start the video in just a minute, I'll show you the solutions. Okay, and the solutions, I have them worked out on this side, the examples. So the solution to the first one should be 6x plus 3 over 2x. The solution to the second one should be 7x minus 12 over x, and the third one just x plus square. Okay, these are also really good examples. The first one here, for letter A, in the numerator, notice we can factor out a 6. So we've got 6 times a minus b, and in the denominator we have b minus a, which they're really similar, aren't they? And naturally we want to just be able to cancel our a minus b's. Notice that if we have b minus a, and we want this b minus a to mimic a minus b, that's actually going to be equal to a negative a minus b. That's what this is telling you here. And the way that works is, look, if we were to distribute this minus, we get negative a plus b, or in other words, b minus a. So these are equal to each other. So we can rewrite the denominator b minus a as a negative a minus b. And the reason that helps us is because then we're able to cancel. We get a 1 and a 1, so 6 times 1 gives us 6 in the numerator, divided by a negative 1 in the denominator, or in other words, just a negative 6. Okay, and then part B is similar. So we've got xy squared minus xy over 1 minus y. So okay, so we factor what we can from the numerator, so we have x, y in both terms, and xy times y gives us xy squared minus 1 over 1 minus y. So we can turn this 1 minus y into a y minus 1 if we factor out a negative. So if we factor out a negative 1, we can change this to 1 minus y. And again, just to show you how that works, if we have 1 minus y, it's going to be equal to a negative 1 times y minus 1, because look, if we distribute this negative 1, we get a negative y plus 1, or in other words, y minus 1. So they are in fact equal. So we can replace this 1 minus y with our negative 1 y times y minus 1. So now that allows us to cancel our y minus 1s, and we've got xy divided by negative 1 dividing by -1 is equivalent to multiplying by -1. So we've got a negative xy. Okay. Again, here we're going to continue to rely on our previous knowledge, and anytime we're faced with an algebraic fraction, we're always going to simplify first by factoring. So this x squared minus 1, we can factor to x plus 1 times x minus 1, and x squared plus 3x plus 2, that factors to x plus 1 and x plus 2. And again, we can't, from what we started with here, we can't cancel anything because in between our terms, we have addition and subtraction. So we have to factor it in order to have multiplication in between our terms. So now we can cancel our x plus 1s, and we're just left with x minus 1 over x plus 2. So again, anytime you're faced with these algebraic fractions, you definitely want to look at what factors can I take out? How can I factor both the numerator and the denominator? Okay, multiplying and dividing algebraic fractions just takes simplifying one step further. So remember, when we multiply fractions, we can just multiply straight across. We don't need a common denominator. That's just for addition and subtraction. If we're dividing, we can take the original fraction, a over b, and we can multiply by the reciprocal. So we can switch our fractions. So we, instead of c over d, instead of dividing by c over d, we can multiply by d over c. And again, you'll just multiply straight across. And then it's really important, this last step, that we do write our fractions in simplest form. It's not complete until you have simplified your final solution. So we're going to look at some of those examples. Here we have 4 over d times d over 8. We're going to multiply straight across, and we get 4d over 8d. And again, we just need to make sure this is in simplest form. So because we have 4 times d and 8 times d, we can cancel our d's, and we can also cancel 4 out of both 4 and 8. So 8 is 4 times 2, 4 is 4 times 1, so we're left with just 1/2 as our solution. Anytime you have a constant or you're multiplying a fraction by something that doesn't have a denominator, we can always put that over 1. So what we have here is 5 over g times g cubed over 1. And again, we can just multiply straight across. So we've got 5g cubed over 1 times g. And again, we just want to make sure our answer is given in the most simplified form. So we look and see if there's anything we can cancel. G cubed is g times g times g. And in the denominator, we have 1 times g. So of course, we can cancel one of our g's. Or in other words, we've got 5g squared, or g times g, over 1, or just 5g squared. So this is just a review of division. You can see this example here. If we've got m over 2 divided by n over 6, we multiply by the reciprocal of the second fraction. So m over 2 times 6 over n. So we flipped the second fraction and changed it to multiplication. So we multiply straight across, m times 6, 2 times n. We know that we can cancel a 3 out of both the 6, or sorry, a 2 out of both the 6 and the 2. So we're left with 3m over 1n. Okay, last couple of examples. Here we've got division, so we can change it to multiplication by multiplying by the reciprocal of the second fraction. So we get 6x squared over 2x. And again, we want to simplify our fraction, look for anything we can cancel. So from this x squared, that means x times x. So of course we can cancel an x in the denominator and an x in the numerator. We can also cancel a 2 from both of these terms. So 6 divided by 2 gives us 3, and 2 divided by 2 gives us 1. So we have 3x left, and that's over 1, or just 3x. If we rewrite the second equation, we have 8 over p divided by 2 over 1, right? We can always put our constants over 1. So if we change that to multiplication, we have 8 over p times the reciprocal of 2 over 1, which is 1/2. And we can multiply straight across, so we get 8 times 1 is 8 over 2p. And we look for any terms we can cancel, and we know that 8 is divisible by 2. 8 divided by 2 is 4, and 2 divided by 2 is 1. So we have 4 over 1p. And that's it. Hope you have a nice evening or afternoon, whatever time of day it might be. See you tomorrow.